Test to make sure that my Mars video will work. Test. Check, bitches. Hello. Fuck. Hi, thanks for checking out my YouTube video. Today I'm here to make the case for Mars and why we must settle this red planet. It was only 40 years ago that Neil Armstrong landed on the moon. Not Neil Armstrong, mankind. We left our planetary cradle. And even if you are too young to have been alive when he did this, you've seen the video and you've heard the wonderful words. This is one small step for a man, one giant leap for mankind. And it was. But looking back, it's a lot like Leif Erikson's journey to Canada. He came, he stayed for a year, and then left. And that's what we did. We found this new resource, this new planet. We left our planetary cradle, and we didn't go back. We gave up. And today I'm here to prove to you that we can go to Mars. And I'm here to make a case on why it is the best idea for you, me, and all of mankind. Firstly, is this a crazy dream? The answer, no, it's not. In fact, in 1971, NASA engineers began creating plans to take mankind to Mars by 1980. However, when the Nixon administration cut the funding and Bush Sr. cut even more funding, that dream was given up. But so they had a plan, and this plan took into account all the challenges. The first challenge is getting there, and they figured that a trajectory from Earth to Mars would take 180 days. A conjunction class mission. What that means is we fire the rocket on an angle towards Mars, and we wait for it to catch up to where the rocket is. That way they don't have to travel as much as the distance to keep up with the planet, because it will meet them. This will take about 180 days or 6 months. The other problem though is fuel and weight of the vehicle. We could create a supermassive spaceship like Battlestar Galactica or the Enterprise on Star Trek. But that's kind of ridiculous. We don't have the funding or the know-how how to build one. Or we could simply use 2 Saturn V rockets. They're now called Ares rockets, and they're the best equivalent. What you do is you fire one, the Earth Return Vehicle, or the ERV, to Mars and land it on Mars. You only have to send it with a fraction of the return fuel. Just send it with hydrogen gas. The hydrogen gas will then form and mix with the carbon dioxide in the presence of nickel catalyst to produce methane and oxygen gas. This experiment has been replicated before on Earth by Professor Robert Zubrin. And then we can have enough fuel. And then a year later, when the manned Mars mission goes, they know they have enough fuel, a place to stay, enough fuel to return, and a place to stay on Mars. So we can do it. The team would leave 6-month journey there, 6-month journey back, and they would stay for 550 days, about a year and a half, on the surface of the planet. While on the surface, they will do mostly exploring. They will look for signs of life. They will look for wells of water. They will look for geothermic activity. They will look for mountain ridges, etc. Because Mars is a lot like our planet, it's only 500 million years older. Since it's 500 million years older, that means it has a lot of the same properties as the planet Earth. It has the same soil compositions. In fact, it has more nitrogen. However, Martian soil contains iron and silicon in larger amounts than terrestrial soil. And iron and silicon are very useful for human production and life. Secondly, that means that it has water. And if we can find water near an active volcano, that means it's heated. And we can then use that to produce geothermal heat and eventually electricity and power. Successive missions can be then sent to the red planet. And they will then discover new sites, new sources of water. Eventually, we could send a mission that's tended to stay there for longer. Maybe a double mission. Stay there for 3 years. Stay there for 5 years. Stay there for 8 years. And they will bring all the habitats that have been left together to form a small community. They can then begin drilling. We can send heavier equipment there if we don't need to send as much to return home. They can begin constructing domes over the land and try to farm on Martian soil. All this is a test run for when humans form civilization on Mars. So as you can see, it's a totally possible dream. It's a goal that we could do. We could prove that humans are a seafaring race. But then the next question is why? A lot will complain that it costs a lot of money. Well, getting to the base building stage of Martian exploration would cost $60 billion. I admit that straight out. However, think about what countries around the world are doing. Every country has a stimulus package. The United States, Canada, Mexico, China, Finland, France, England, Spain, all have stimulus packages. And if we spent a little bit of that, of each stimulus package, we could achieve the goal of stimulus, to create jobs, to create educational opportunities, and to create something tangible that the government needs. For $60 billion, think about that. That is 1/10 of the American stimulus package. That is 10 times less than it cost to fight the war in Iraq. That's just over the cost, of the war in Afghanistan, minus the human death toll. We could have a base on Mars for that money. We could have jobs, we could have people employed, and we could inspire students to become engineers, to become scientists, because nothing would inspire my generation more than a goal like we're going to Mars. The second is, what would benefit us? Well, that's a lot like asking Christopher Columbus, what will come of the United States of America? He wouldn't have known that it would have come to be. We look at the Apollo program. It gave us the internet. It gave us computers. It gave us satellites. All of those things, if you ask someone from 1950, they couldn't have possibly fathomed that. And that's what it gave us, and that's what are staples of our modern society. And we look at the greatest challenge of my time will be. It will be to fix global warming. And combustion can't happen on Mars, because there's no oil, and oil has to burn with oxygen. On Mars, silane will be used because it burns with carbon dioxide, producing oxygen, which we need anyways. They'll also have to produce electricity in ways that can be mimicked on Earth without oil. So we could solve our greatest challenge on Mars and bring the technology back to Earth. That would also make it profitable here on Earth, because we would have all these new technologies flooding in from Mars. And because of this immense technology, bringing people back to work, and proving that humans can fare on land, on sea, in the air, and in the galaxy. Think about that. We must do this. Not because it is easy, but because it is hard, and what is hard is truly rewarding. Thank you, and I hope you consider Martian exploration. Please look at The Case for Mars, written by Robert Zubrin. Search the MarsUnderground.org and look at this. Encourage your government politician to take us to Mars, because as a species, we must. Thank you very much.